this is Mr. Coates, and this is APES lecture number
40
on acid deposition. We've been talking about air pollution, and one of the effects of air pollution is the deposition of both wet and dry acids. And normally we call this acid rain, but there can also be dry deposition as well, so it's not all acid rain. This picture here shows you a picture of a forest in the Appalachian Mountains that has been severely damaged due to the acid rain precipitation in this area. And you see these trees here are all dead, and you can actually see back here on this hill with lots of dead trees as well. And acid deposition create a huge problem for especially pine forests where the soil is already acidic. You can also have problems with crops, and we'll also look at how acid deposition affects our man-made structures. So how does acid deposition or precipitation occur? Well, remember we have all these pollutants coming up, and so we can have nitrogen oxides, we have sulfur dioxides, and those things combine with water in the atmosphere. Then as the water starts to condense, that water falls. Now rain usually has a slight acid pH to it already, but when you add these things to it, the pH lowers even more. And so you can start having dry acid deposition sometimes from sulfur dioxide gas particles and sulfate and nitrate salts. And you can have wet acid deposition from rain and snow. You can even have acidic fog. And all of these are huge problems due to air pollution. So what are some of the effects of acid deposition? You can have huge problems with fish kills. Some fish are highly susceptible to changes in pH. Trout, for example. Trout do not like changes in pH. They like their water the same all the time. They have a very narrow tolerance for pH change, and if you have a large rain event that has quite a lot of acid incorporated into it, you can shock the fish to death in there. And so this happens quite a lot in the northeast United States, where our acid deposition is the worst. Also, we can harm the forest. We already saw a picture of that, but basically by stressing the trees, you can reduce their ability to fight disease. We leach nutrients out of the soils. The acids will take those nutrients and move them out of the soils, and it can cause excessive nitrogen level in the soil, and then basically releasing NOx gases to the atmosphere. And then in our cities and our infrastructure, the acid deposition can start eroding those things away. Remember, a lot of our infrastructure is made out of cement or limestone, and cement and limestone react with acid, and the acid causes these things to dissolve quite readily. If you look here, there's a before and after picture of a limestone statue, and I think this is somewhere in Europe, I'm not sure. You can see how it used to look versus how it looks now due to the acid deposition. And if you think about the amount of acid deposition in this country, and you think about all the bridges out there that are made of concrete and the buildings made of concrete, we are slowly dissolving our infrastructure away. And eventually our bridges and things are going to need to be replaced because of this continual weathering by this acid deposition. Other health effects include respiratory diseases, especially if you get some of that acidic fog and you breathe that in. Once again, it can burn lung tissues and your nose tissues and cause bronchitis and asthmas. When we drain acid deposition into lakes, a lot of times we dissolve aluminum ions, and aluminum ions can cause fish to asphyxiate. They don't allow the fish to uptake oxygen with their gills, and so this can be a huge problem with fish in lakes with too much aluminum. And then, as I mentioned before, a lot of nutrients can get leached out of the soil for crops and also for forests, and you can have a huge problem with trying to keep up with the amount of nutrients in your soil. Alright, so when we look at our pH, we're going to look at sensitivity of aquatic specimens, and the first one we're going to do here is remember our pH scale. Our pH scale is basic up here, so this is basic, and then we have acidic down here, and neutral is right about here at 7. Most of the time, regular rain is usually right about here at 5.6, and this is non-acidic rainwater. This is normal rainwater, and the reason why the pH is lower here is because rain, as it falls, mixes with carbon dioxide in the atmosphere, and when water and carbon dioxide mix, they make carbonic acid. But this is a natural thing, so we're not too worried about that. However, we start getting down into lower areas here of lower than 5 into the 4s. We start having some huge problems here with acid deposition. So things like brown trout, I mentioned trout being very sensitive to pH changes, and they like pH around 6 or a little bit above. We start to see crayfish dying also at pH 5. pH 5 tends to be the most important pH there. Anything once we start getting below pH 5, we really lose all kinds of things. The food chain starts to get affected down at 5. Brook trout die at 4.8, and then all fish are dead at 4.2. And so if we have a pond or a lake that does not have the ability to keep the pH where it's supposed to be, we can really drop the pH quickly, and we do that, as I mentioned earlier, we shock the fish. That usually causes a fish kill. And when we have acid deposition on soils, typically acidic soils like coniferous forests and taiga, these soils are already acidic, and so when that happens we start to lose our potassium and our calcium and our magnesiums out of the soil and down into where the roots can't get to them anymore. And sometimes they're even put into the water table, and then we can pump them out and drink them. This decreases the soil pH over time, and the more and more soil pH decrease we have, the less our crops and trees will grow. In Florida, we don't have that big a problem. We have what we call buffers in our soils. A buffer is anything that resists pH change, and limestone is a very good buffer, and thanks to limestone here in Florida, we don't have huge problems with soil acidification. Now, if we look at the distribution of hydrogen ion concentration is the measurement of how acidic something is. So the higher your hydrogen ion concentration is, the lower the pH. And so if we look at our pH here, in the northeast is where we have the biggest amount of pH drop. And we looked at Appalachian Mountains, which are right in this area before. And this is because of all the coal burning power plants that occur in this area. They're releasing all kinds of sulfur dioxide, nitric oxide, and so all of this is in fact reducing the pH of the rainwater. As we get further away from the east and away from those power plants, we start to get to more normal pH levels for rain. Now, although I mentioned our soils don't get too bad of pH problems, we do have a problem with the acid deposition in the state of Florida. And only down south, where we get away from a lot of this coal burning power plants, do we actually get away from the acid deposition in Florida. Remember, we do have a major coal burning power plant right here in Tampa Bay, and that does put that sulfur dioxide into the atmosphere as well as nitric oxide. But our biggest problems in the United States right in this area here. Now, how can we prevent acid deposition? One of the ways is to use low sulfur fuels. For example, diesel. If you buy diesel nowadays, you can actually buy a low sulfur version of diesel. And so that's the best version to buy, although of course it's more expensive because the sulfur's been removed. But that's the best way to prevent that. We can also go to other types of electrical generation, getting away from coal power plants and getting to wind generation. We can get to solar, and we get to hydroelectric, and none of these put acid deposition in the atmosphere. Now, if we already have acid deposition and our lakes are starting to have problems, we can always buffer our lakes with things like limestone. And this is a picture of a company that's actually washing lime into a pond that has problems with acid deposition, and this lime will help buffer that pH so it doesn't change that much. And then the last and least effective way is to start installing pollution control measures on those coal burning power plants, things like scrubbers. And later on, as we get into air pollution, we'll talk about what these scrubbers actually do, and the fact that they actually remove sulfur from the smokestacks and how they do that. If China started installing scrubbers into all of their power plants, they would really reduce the amount of SO2 in their atmosphere. And this is one of the things that the United States has done. It's due to the Clean Air Act, and we'll look at that in a little bit. Well, I hope you learned something a little bit about acid deposition and how to avoid it and what it's all about. And next time it rains, have some buffer around. That's the best way to protect yourself.